So the very last page of these notes has to do with common misinterpretations from actual AP Stat students. So let's see what their interpretations were like, and then let's correct them. Number one, a biology student who created a regression model to use a bird's height when perched for predicting its wingspan made these two statements. Assuming all calculations are done correctly, what is wrong with each interpretation? Part A says, my R-squared value of 93% shows that this linear model is appropriate. So that's absolutely wrong, but why is that wrong? So R-squared being 93% doesn't show anything about the linear model. For the linear model to be appropriate, you have to actually refer to the residual plot and say there's no pattern in the residual plot. And then the other component where the student would lose points is that this response lacks context. So a correct interpretation, if the R-squared value was really 93%, we should say 93% of the variation in wingspan, the thing that the model predicts, can be accounted for by the LSRL that relates wingspan to the bird's height. So that follows the same approach we always use for R-squared as far as using context. So that would get full credit for part A. Part B, it says a bird 10 inches tall will have a wingspan of 17 inches. So it looks like the kid used 10 inches, plugged that into LSRL, and the output was 17. The issue is that this is too confident to say that absolutely a bird that's 10 inches tall will definitely have a wingspan of 17. So the fact that it says that it will have a wingspan of 17 is wrong. We should say a bird that's 10 inches tall is predicted to have a wingspan of 17 inches based on our line. So if we don't say something like this bird is predicted to have this wingspan, or on average it will have this wingspan, or is expected to have a wingspan of 17 inches based on our line, okay, then that would be off, right? This would lose points the way it's written. Number two, a sociology student investigated the association between a country's literacy rate and life expectancy, then drew the conclusions listed below. Assuming all done properly, explain why each statement is incorrect. The first statement, part A, says, since R-squared equals 0.64, the literacy rate determines 64% of the life expectancy for a country. Okay, that's definitely incorrect because we can't say that R-squared determines 64% of the literacy rate. We can say for R-squared, if we do it correctly, the LSRL that predicts life expectancy by the country's literacy rate, so it predicts the Y category, which would be life expectancy, based on the X category, which would be literacy rate, is what accounts for 64% of the variation in life expectancy. So that's like the correct interpretation of the R-squared value here. Part B says the slope of the line shows that an increase of 5% literacy rate will produce a 2-year improvement in life expectancy. Would actually be okay here. So if we think about the slope, if it's 2 over 0.05, in this case 0.05 would be the literacy rate, which is our X variable, and then 2 years would be like the life expectancy. So for an increase of 5% in the X, we have a 2-year increase in life expectancy. The issue with this problem is that it says it will, right? And we saw this earlier. If we say something absolutely will increase, that's not correct. It should actually say is predicted to increase by 2 years. So unless we say it's predicted to or on average, this would lose points by saying for an increase of 5% literacy rate, the life expectancy definitely goes up by 2 years, right? That's incorrect. We have to say our line predicts it will increase by 2 years. All right, so there's a couple AP exam tips on the bottom of this page. There's also a comic. I'm going to leave those to you. So that is all for these notes. I'll see you in class.